Uh, Good afternoon, everyone. I think we can start now. Uh, am I audible?
Yes, sir. Good afternoon.
Okay. Okay. So we already know that in electrical engineering system, uh, we cannot predict anything in a sense that so far, whatever electrical system, engineering system actually reported, any kind of electrical engineering system reported so far, they cannot actually predict means what will come next or what is going to come in the future. Okay, so that is why this these types of systems are basically called the causal systems. And actually, so the causal no the another name of this causal system is basically, that is why people call it a realizable system. That means the system which you can realize in practice or in reality actually. But when we if we cannot realize a non-causal system, mainly whenever we are talking regarding this causal, non-causal, etc., so always think from the perspective of an electrical engineer. Okay, now if we cannot realize this kind of a non-causal system, I'm talking in terms of a system, particular system, then what is the use of talking about that? Means in other way you can say, if all the systems, all the electrical systems concerned are causal, then why we are talking of it, why we are talking about it, what is the need of specifically pointing this particular term now? And again, or in other word, you can say why we are trying to make a distinction, between these causal, non-causal. Some systems are said to be causal, some are non-causal, something, because we know that realization is not possible of this kind of non-causal system. Now, this distinction, you should understand this very carefully. That distinction actually arises, basically because of the non-causal signal processing. As far as the non-causal signal processing is concerned, that is possible to do on a recorded data. Mainly, what a system does, what actually system actually process on the signal that you are feeding into it. That means the input, process it and produce in a better or a more desired form the same signal in a more desired or in some better form. So basically, whenever you talk about the system in general, you should understand that it is doing some kind of processing, even storing, or even giving some amount of delay is also called processing. Okay, may not be the processing is very complex, very simple, just to store. It is storing for some time or some sample duration. It is just storing it, or it is just storing for actually storing and delay in actually the same thing. Two different way to look into the almost the same thing. That is why I am not trying to distinguish between these two at this point. Anyway, so whatever, that is also simplest thing, just to give it something, some delay. That's all. Delay element or storage element. So whenever we will talk in terms of the signal processing, and the system doing some kind of processing on a signal, that is called the signal processing. So then it is possible to do on the recorded data. It is possible. It means then only non-causal realization is possible. That means if you have a recorded data and if you do some kind of processing on that, then non-causal, then the system is called non-causal. It is possible. Suppose I'm giving an example. I think that will be helpful for you. Suppose take the example of suppose there are geophysicist. Okay, geophysicist, for example. Now, what and geophysicist actually does? Geophysicist, or a group of that group, actually, what they do? They actually go to the field, record by what is called the seismographs, the vibrations, and record all those data, all those things they actually record. Okay, and then they get back to their laboratory or their chamber, their office. They come and then analyze that data. So the data has already been recorded. Data is already been recorded. Please note, record, I'm using the term record again and again. So data has already been recorded. So when they were recording the data, that was the real-time data when they were recording at that time. But once it recorded, then it is not real time. Okay, when they're extracting or taking the data or recording the data, at that time they were real time, because with time that was varying at that instant. But once they have recorded it, they just it is no longer a real time. Suppose in our department, there are different sophisticated antennas and machineries on the roof top, and that actually capture different signals, natural signal. That means, suppose the rainfall, the humidity variation, the temperature variation, fluctuation, etc. So it is already, you will get some flavor in our department also. Okay, this kind of how to capture and operate on those recorded data. You will get that exposure. Don't worry. And there, the concept of non-causal signal processing and hence non-causal system comes into the picture. So anyway, the example what I'm trying to say, that suppose you have recorded this kind of data, and then you go back to your chamber or room or laboratory and then start analyzing it. Now, basically, when you are doing this analysis on a particular output, suppose say for example y of n. Okay, now you already know what is going to come because it's the recorded data. It is recorded data. So a recorded data means on recorded information, this kind of non-causal signal processing is possible, because at any instant of time, suppose you have a set of data, at any instant of time, if you fix it, you can say that is my zero instant or current instant. Whatever data is there before that, okay, or prior to it, so those data you can say that are past, and those that are coming after that, you can say those are the future things, something like that. So that means it is when you are analyzing a particular output, suppose yn, it is you know what is going to come. Because yn, suppose you are analyzing for a particular xn, suppose, and already at that time that is when you are analyzing. Please note the term. When you are analyzing, that means at the current instant, when we are doing the processing on the particular input xn and producing yn, at that time what are the next input that is going to come. That. This is not possible in practice. This is, if you work on the real-time data, it is not possible, because you don't know at the very next moment how it will change. You don't know if it's a real-time signal. But in a recorded data, whenever you are processing at a particular instant, and producing some output on a particular input, and what are the next, the signals or samples that is going to come, that because that is already in a database. So recorded on recorded information, you can say that non-causal signal processing is possible. So in particular, this kind of, this geophysics or this kind of areas in particular, suppose regarding weather predictions, this kind of things, in these areas, rather, this non-causal signal processing is a very, it's a routine task, a job, and it is possible there. Every now and then, those people actually do it. But we cannot realize this in hardware. Please note, we cannot realize this in hardware. It is a data processing basically. Hardware realization has to be causal. Hardware realization always has to be causal. We cannot anticipate what is going to come. You cannot realize a hardware that can anticipate what is going to come. Are you getting my point? It is a bit tricky to understand. Very subtle concept is hidden, but you should understand it very carefully. If you follow carefully, you can understand. I should explain it once again. Okay.
Yes.
Okay.
Yes.
Okay. The point is that in mostly we basically talk about the non-causal and the non-causal system. Now we already know that non-causal system realization is not possible, because non-causal system means the system that can actually predict what is going to come next or something like that. That is what is going to come in the future. It can, or in simple word, you can say they actually behaves like an astrologer. That what will happen in the future, they can predict something like that. This is the system. So what is going to come in the very next instant or next to next instance, like that. But it is not possible in electrical engineering system, as I've mentioned. It is not possible. There is no such system till date which can predict. That is no such hardware which can predict actually what is going to come in the future. In that sense, all the systems are causal. All the systems are causal. That is why the another name of the causal system is, please note, realizable system. That system which you can realize. Any system that you can realize will become causal by default. That is called the realizable system. Now, that is then in this context, I have asked this question that if everything is causal, there is no concept of any non-causal system, because whatever I will talk in the perspective from the perspective of an electrical engineer or electrical systems, because we are an electrical engineer. Okay, so don't think from other perspectives. So then the question that may come is that then why we are specifically mentioning a term non-causal? If everything is causal, supposed to be causal, then why non-causal? Means if we cannot realize the non-causal, then why we are talking about it? Why we are mentioning the term? Okay, so why we are trying to kind of making a distinction between the the causal and the non-causal? These are the possible questions in this context. Now, actually, the distinction arises, as I mentioned, if you think from the perspective of signal processing. Signal processing, with actually non-causal signal processing is possible. And it is possible if it process on the signal, means if the system process on the signal or the data which is already recorded. That was the recorded data. If the signal or the data is not recorded, that means it's real time, then you cannot say that my system is non-causal. So whenever we talk in terms of the non-causal system, we basically try to mean or indicate that it is related to the processing, signal processing, how the system is processing. It is basically processing. When it is processing a particular input to produce a particular output, at that very time, the next data, those are yet to come, are available. Okay, so when you are analyzing a particular output yn for a particular input xn at a particular time, you know actually what are the data that is going to come next or next to next or something like that. Successively. So on recorded information, this kind of non-causal signal processing is possible. Like the example of geophysicist or this kind of example I have just given. But you have to understand that we cannot realize this by hardware. You cannot realize a hardware which can predict. It is basically data processing. Hardware realization always has to be causal. So in that sense, we cannot anticipate what is going to come.
So by hardware, you want to mean like by any device or something, like they're putting an input and by the output, we can't get a future output. Like the hardware is predicting some future output. That is not possible. But
hardware cannot even predict the future input. If it cannot predict the future input, how can it produce
the future output, right? And but the data that we are collecting, like every day, like for any experiment we have collected and data, by that we can see by the nature of the data, we can predict what can be the future.
That is possible. That is possible.
That is like, you want to mean those kind of things is a non-causal part, but the hardware part is a causal.
Yes, hardware part is the causal, but those kind of things, due to the nature of the processing concern, you actually define or classify it as a non-causal system. That's
all. Okay.
So if that is related regarding the system, and if anyone asks you about the signal, whether all signals are causal, If this is the question, then actually formally any signal, suppose xn, is causal if you know the definition very well. I'm just repeating it for you. If xn equals to 0 for n less than 0. This is the definition you all know. The definition of a causal signal, xn is 0 of any signal xn, that is 0 for n less than 0. That means what? We have to start the signals at some point, okay? And it is better. It is a conventional thing that you should. It's a convention actually that you should mention or call that point as n equals to 0. That is the present instant. I have used this term several times. Probably you have noticed the present instant. And from wherever you will start, if you define that as a present instant, that is n equals to 0, suppose, okay, or t equals to 0, then obviously that is causal. Then that is a causal signal, because ultimately you have to start from somewhere, na? And from wherever you will start, if you put it that n equals to 0 or t equals to 0, it will automatically become causal. But if we have the values, suppose for suppose x equals to minus, the argument in general, the argument is minus actually. So any value of minus 3, minus 2, minus 1, etc. X XOR and so on. Then this is not a causal signal. Again, signals can be non-causal. That is possible. That is, we can start the processing, suppose that n equals to 0, and but you know that the initial values, that is x of minus 1, value or values, x of minus 1, minus 2, minus 3, and so on. That is possible. That also be possible. Now, if we combine all these, then it is a non-causal signal. That means you have the present values and the future values, and you have the past values as well. If we define like this, then it is possible that you have the present, you have the past. That means for both the plus values and minus values of n or t, you have the signal. So mostly we talk of the causal signal, mostly. But it is possible to define in this way, the way I mentioned. It is possible. And you have already have seen lots of examples regarding that. Okay. Now, actually, in this particular context, I want to mention another point, that there is another term that is used, that is called the anti-causal. I think already you are aware, but still I am mentioning. So anti-causal is just anti, or the opposite of causal. That means the definition of causal actually implies that you have the value of the signal or the samples starting from n equals to 0 onwards for the positive values. But if and for negative values, you don't have any sample or any signal. But if you have if the scenario is just opposite, that means if you have only the sample values or the signals exist only for the negative values of n or t, and no positive value, nothing exists. This is called the anti-causal. And if you have some, means for the negative value, some values for the positive, and so on, it's the kind of combination of these, it is called the non-causal. Okay, so basically, you can understand that actually all anti-causal signals, now in this context, all anti-causal signals, you can define, or you can say that the anti-causal signals are not, the non-causal. Can I say that? But all non-causal signals are anti-causal. Can I use this statement? If we use this statement, whether I am correct or wrong? All anti-causal signals are non-causal, suppose, and all non-causal signals are non-anti-causal. Anyone, please? Whether this statement is correct or not? We can say
it's correct.
Correct. Okay. Is there any other type of answer? Any other type of answer?
Correct, sir.
Correct. Okay. Now explain why it is correct. Explain why it is correct.
So for anti-causal systems,
System, no,
the
I'm not
signals,
system. I'm talking about signal.
sorry. The anti-causal signals, the signals values are only possible for the negative values of n and t. And in case of, if you consider the non-causal, they are also possible for negative as well as positive or zero values.
No,
So it's
just a small
the
correction.
anti-causal are the
Just a
subset.
small correction. You told that for anti-causal signals, the values are possible for negative values of a not t. Actually, not only for negative, but also for the zero. You have to count a zero also. Please note that. Again, otherwise that issue will come. If you can't define the zero or the present instant, then you cannot use the pivot element. And you cannot actually define or point out the reference or the pivot element with respect to which you basically say it is by negative or positive. Okay, so basically that exists anti-causal signal actually defined for, means the definition should be something like that xn equals to 0 for n greater than 0. Are you getting the point? Xn equals to 0 for n greater than 0.
Yes, sir.
Like the way you define the causal signal, that is xn equals to 0 for n less than 0. That means for 0 and for all positive values concerned, they exist. Similarly, for anti-causal, for the 0 and for all negative values concerned, they exist. That is the thing. But for non-causal, what I'm doing, non-causal is exactly, you are right, that anti-causal signals are basically a subset, you can say, a subset of the non-causal signals. That means you can say that all anti-causal signals are basically non-causal, but all non-causal signals are not anti-causal. So this kind of statement can be written, and it may be asked that you just explain it with a small example. So you have to do it by your own. It is very easy. This kind of question, to answer this kind of question is very easy. If you understand the concept, then you can easily answer. Okay. Anyway, so with this, I should move to another topic that is related to that. Just a minute, I have to share the screen. আচ্ছা, দেখতে পেলে আমাকে একটু বলো, শেয়ার স্ক্রিনটা দেখতে পেলে। দেখা যাচ্ছে?
হ্যাঁ স্যার।
আচ্ছা আচ্ছা, এবারে কয়েকটা জাস্ট আমি মানে আরেকটা মানে একটু রিগোরাসলি অন্য টপিকে ঢোকার আগে আমি জাস্ট কয়েকটা কি পয়েন্টস একটু ডিসকাস করে নিই তোমাদের সঙ্গে। হ্যাঁ, একটু কয়েকটা কি পয়েন্টস জাস্ট। সাপোজ তোমরা অলরেডি জানো যে what is the condition for, suppose I mean কতগুলো এক্সাম্পল, মানে I am just taking some examples to illustrate what I'm trying to say or actually. So suppose the signal is cos omega naught n. Okay, this signal, and you know that the condition for this discrete time signal to be periodic, you know that quite well already. You know the condition is that omega naught by 2 pi should be written, if it can be written as a ratio of two integers, okay, then we can say this is a periodic signal. We know that. Now in this particular context, if you see that omega 0 by 2 pi, it is basically this context. If I take this example, already I have discussed this example, 3n cos 3n, and you can just by looking into this, you can directly say that it is basically aperiodic. So AP indicates aperiodic. Okay, it is AP means aperiodic, P means periodic. Suppose AP, aperiodic. Okay, aperiodic, because you know 3 by 2 pi is not a rational number, that means ratio of two integers. It is not. You already know that. It is a well-known example. I myself discussed this thing in the class. Now Suppose in the continuous time domain, CT indicates continuous time domain. Now suppose in the continuous time domain, you have one periodic signal and you have another periodic signal that is being added. Two different periodic signals are being added. Okay. Similarly, in the discrete time also, you have one periodic signal, obviously satisfying this condition, and with that you have another periodic signal. So it may be two, and you can extend this for even more than two. That doesn't matter. Just one, need the concept. Now, can anyone tell me whether if you add two periodic signal for the continuous time domain, the resultant signal, whether that will be periodic or not? Or is there any rule, or you have to check it or test it? Or you can blindly say. And the same question is applicable for the discrete time as well. If you add two periodic signals in the continuous time domain, whether the resultant signal is for your convenience, let me define the period of the first one is T1 and the period of the second one is T2. Suppose, for example, okay.
So it may or may not be a periodic.
Exactly. You are correct. It may be periodic. It may not be periodic. That means it may be aperiodic. It actually depends on the ratio of these two.
Of that, yes, it has to be a rational number.
It has to be a rational number also. Very good. If it is a rational number, then it will be periodic. If it is not, then it will not be periodic. That means aperiodic. Now, what about this discrete time domain? What would happen in case of the discrete time domain case? Or
sir, in discrete time domain, it should be always periodic, as n is also always a rational number.
Very good. In discrete time domain, if you add two periodic or more than two, these should always be periodic. Always. Very good. Excellent. So 1 mark MCQ question. Okay, you can expect this kind of question. So it will be always periodic. Very good. If this is known to everyone, then just one or two example. You just let me take. Suppose, for example, suppose you have sine 3t plus cos 4t. Just tell me whether it's a periodic signal, the summation is a periodic signal, and if so, what is the period? Tell me quickly. What is the period for the first signal? A period কত? বলো, থেমে গেলে?
Sir, 2π/3.
Very good. 2π/3. এর ক্ষেত্রে
π/2.
কত?
π/2.
আচ্ছা, আমি সহজের জন্য 2π/4 বললাম, ঠিক আছে? তাহলে রেশিও করলে কত পাচ্ছ? T1/T2.
4:3.
If you take the ratio, exactly 4/3. So 4/3 is actually a rational number. So
Yes, sir.
if you add this, the resultant signal will be periodic. That's all. Okay. Similarly, you can take this example also. Suppose you have, one is sine 3πt plus cos 4t. Similarly, you do the calculation and you will find the ratio, and from that you can show that it will be irrational. That means it will be aperiodic actually. You can show it now. And suppose if it is an MCQ question, you just have to tick, okay, or select which one is the correct out of all 4 possibilities. But if it is not an MCQ, suppose in a broad question given, like having a 2 marks, so you have to there specifically mention all these points. That means first you have to find out the period of this. Means you have to, your approach should be very systematic. So then you have to find out the period T2 from here. Then you have to take the ratio, and from that you have to show whether you are getting ultimately a rational number or not. Then only you will get the full 2 marks. 2 marks full, otherwise not. If you just write the answer that is periodic or aperiodic, it's just by observation you can say, but for that 2 marks is not dedicated. So that is true for the MCQ. Please note this. Otherwise you will not get the 2 marks, full 2 marks. Fine. Okay. Now take another example. Suppose suppose in discrete time case, suppose sine, you have 4 pi n, a discrete time signal. Okay. First of all, tell me whether this is a periodic or not. Whether this is a periodic or not.
Yes, sir, periodic.
Periodic.
Yes,
Oh,
sir.
periodic. It's a periodic signal. Very good. Then you just tell me what will be the actual value of n in this, for this signal. N, capital N. That R by N, the denominator N. What will be the actual value of N?
So 1.
Very good. 1. Why 1?
So because it's 2 by 1.
Okay. Suppose you have another signal. Say another example. Cos n pi n. N pi by 4. N pi by 4. You have this. Now first tell me whether it is periodic or aperiodic.
Periodic.
Periodic. Very good. And again, what is the actual value of n?
8.
8. Very good. 8 एक number पे गए. So n is equals to 8. Everyone should do it. These are the very easy exercise. You can do it. Very small problems, very easy problems. Just if you can do it, if you can solve it, you will get 1 marks. Okay, in MCQ, and if it is not in the form of MCQ, then you have to write a few lines. Just that steps which you follow to arrive at this conclusion. That you have to write on your copy. Anyway, the last example is suppose this example 2 plus suppose cos 3t. Is this signal periodic or not?
Yes, sir.
Periodic. What is the value of period?
Twice pi by 3.
Twice pi by 3. So what actually this 2 is doing over here? What is the role of this 2? or impact of these two on cos 3t.
So it is increasing the magnitude
It is
by
increasing.
2.
Basically, it is or shifting the signal cos 3t up. Okay, the increasing its level. The DC level actually changes. তাই তো? আচ্ছা, এবারে তোমাদের একটা ট্রিক্স একটু বলি। অলরেডি তোমরা এটা জানো, বাট স্টিল আমি একটু তোমার সঙ্গে শেয়ার করছি। For example, this kind of operations you are already familiar with. Just let me draw it first. Suppose I have this signal. The signal ranges from -1 to 3. -1 to 3, and is suppose 1 is a value throughout, and it is x of t is a function of t. Suppose this, you have this get function, a finite length signal. It's a finite length signal. The usual operation, mainly the two operations are very much usual, very common, which you have to do quite often. That is the shifting, time shifting, and time scaling. And very often people get confused that whether I should do the shifting first or scaling first, okay, something like that. Actually, there is no hard and fast rule. You can do any operation first, shifting, either shifting or scaling. That doesn't matter, but you should be very careful while doing that, because ultimately you have to remember one thing, that your variable is a t. Variable here is a t. This thing, t, is a variable. That is the x of t. Now, suppose from xt I want to get what is the conventional procedure, because the procedure you are already known to you, you are familiar with, is the conventional procedure that is written in the book. So suppose first you have to do the time shifting. So if you do the time shifting, and suppose the desired signal is xt plus 1, now you know what to do on this. So it is basically t plus 1 means actually if you make this argument equals to 0, your t will be -1. So that means what is supposed to happen at 0, t equals to 0 for this signal, it will happen for t equals to -1. That's all. Yes, t equals to -1. That's all. So that means this signal is actually shifted to the left hand side. That means this is kind of advancing. You are advancing the signal. Now, how to draw it? You know it quite well, that this axis is t. The variable plotted along this axis is still t. Okay. And now what you do? You just basically add -1 with this and -1 with this. So naturally this part, this left hand side, this limit becomes -2, and this limits become 3 minus 1, that is 2. This is -2, this is 2. So the length of the signal, or the width of the signal, doesn't change. Only the minimum and maximum limit changes. So it is kind of shifted to the left hand side. That means now the signal will start from, it will be -2, and it will be 2, something like that, and everywhere it will be 1, no change. Now if you do the time scaling on that, and suppose I want to get this signal 2t plus 1. Now please note, as I mentioned, your variable is t, so you are basically multiplying this by 2. So that means if anything multiplied by 2, that is more than 1, you know the signal will be contracted. That means here the duration of the signal is 3 minus of -1, that is 4. Here also the duration remains same, that is 2 minus of -2, that is 4. Only thing is that this signal is shifted to the left hand side. But here, as you are multiplying by a factor which is more than 1, then automatically the signal will be contracted. That means the width of the signal, the duration of the signal will be reduced. Now, how it will be reduced? The conventional way says that you have to basically see the plot. Again, the variable is t, and it is basically, you have to multiplying it 2 means actually here you have to divide by 2. So if you divide by 2, this term become -1, and this end, this value becomes, at this end it becomes 1. So just to see the duration now becomes 1 minus of minus 1, that is 2. So, but the amplitude remains same, 1. Okay, so you just see as if the signal is compressed. Now, this is the conventional way. There is no means in step by step. If you do, you will come up with a perfect or error-free answer. But suppose if you have to do it in one step, in a single step, a kind of an MCQ, you don't have much time to analyze so much things and cross-check or doing some kind of thing. So there you have to apply a trick. The second method that I'm applying, so directly just by looking into the signal, you can draw. So the trick is here you have to basically the final. What is the final signal? Final signal is this 2t plus 1. That is the final signal that is desired. You want to get this signal from this signal. So in doing or in getting this signal, you basically follow the two-step process. The first you did the time shifting, and then you did the time scaling. You can come following the alternative approach as well. First scaling, then shifting. Anyway, but I am not interested in the conventional method. Conventional method is already known and well discussed in the books. But suppose for an examination, okay, or for MCQ types of question, if you have a very short time to answer, so there you cannot go for this kind of analysis step-by-step procedure. Okay, there, suppose what you have to do, you have to convert. Look at the final argument, 2t plus 1. And the initial argument was t. So basically, you have to convert this 2t plus 1 into t. So you have to convert the 2t plus 1, this argument, into t. That is the thing you have to do. So how to do it? It implies, means what I'm to say is that how to convert this 2t plus 1 into t. Very simple thing. Just 2t plus 1, write 2t plus 1. First, subtract the 1, then 1 will be cancelled. And then you just divide by 2. Then ultimately what you will get is nothing but the t. So this kind of conversion from 2t to t. Okay, in this way, that means first you have to do a minus operation, and the value that will be subtracted will be 1. And then you have to, after that, after the subtraction, whatever the remaining value will be there, that will be divided by the 2. That is the thing you have to do. That means in the numerator, you have minus 1, and the denominator, you have 2. So subtract 1 and divide, the rest should be divided by the 2. As simple as this. You just see, you have done just exactly that thing. You actually subtracted 1 and divided it by 2. So instantaneously you can find out this thing. And it's just after looking the signal or observing the signal, instantaneously you can draw this signal without wasting a single moment. So if you understand this tricks, this concept ultimately. So suppose, for example, suppose you have this signal, this triangular signal. This is xt, this is t, this is suppose -3, this is suppose 6. You have this kind of picture. That is xt, the plot of xt actually. Now, what it desired is that you have to plot x of -2t plus 3. Final argument would be something like this. So this kind of signal has to be plotted from this xt. Fine. So -2t plus 3. Now the trick says that you have to basically convert this argument to t. How to convert it? First from this -3 and then divide this by -2. Then you will get x of t. Getting the point? Now, if you do it, instantly I can plot this thing. Just you see, just first -3, subtract -3, subtract 3. Okay, subtract 3. So that means from here as well as from here. If you subtract 3 from here, it will be -6. And then if you divide by the -2, then it will be 3. So that means 3. And here it will be, so it will be 3. And this, if you subtract 3, then it will be 3 divided by the 2, minus 2, then it will be minus 1.5. So from here, what we will get is minus 1.5. So that means what is happening? This is minus, this is plus. So this side comes at this side, and this side goes at that side. So that means this signal is kind of flipped. Not only it scaled, okay, in the time domain, but also it's got flipped in the operation of the scaling. It actually got flipped. So the picture should look like something like this part will come at this side, and this part will go at this side. So this signal is x of this minus 2t plus 3, and this will be 3, and this will be minus 1.5. As simple as this. You don't need to think anything else. You don't need to cross check. You don't need to do any kind of analysis, nothing. Almost instantaneously you can do it. Okay. So in this case, it is kind of a mirroring or kind of reversing order or flipping of signal happens because of that minus. That's all. So simple it is. So because in most of the cases, it happens that people get confused. What to do, how to do, what step to follow first, or so on and so forth. Okay. Anyway, so now let's go back to our original discussion. So after discussing regarding about the causal systems and causal signal little bit, because already you are familiar of these things, let me first introduce another important performance metrics for analyzing a system, and that is called stability. Stability. It is whenever we want a digital oscillator, suppose that all the digital system has to be stable. But it means except the digital oscillator, all the digital systems should be to be useful should be stable. The only point is whether the oscillator is stable or not. That actually depends on some condition, and you have no other way. It means all the digital systems have to be stable. There is no other alternative, no other way. And actually, in your analysis, mainly the stability means what is called the so-called, the name Bibo stability, bounded input, bounded output stability. It's a very famous term. Now, what is the definition is also known to you, that if I define this stability in the context of a discrete time or digital system, then you know the definition. Suppose if that mod of xn is suppose less than infinity, that means you have some values b of x. Suppose you can define a value, the b of x. The value of all the samples for this xn is less than that, and this b of x is again less than infinity, and that is true for all values of n. If this is a condition that could be maintained by the input, then, and if that ultimately leads to the output y of n, this all, that means it indicates that all the input samples or the total overall input signal is bounded. And if it leads to or produces the output, okay, which actually again, that can be defined, all the samples of the output is less than a particular value, suppose by, which is again less than infinity. That means this is a finite value, and this is less than that. So it's a style to define, actually it's a way to define it. That means if the input of a signal or a sequence is bounded, the output sequence is also bounded, then the system is called the Bibo stable system. Okay, that means if you feed a system with the input signal whose all the values, okay, concerned are bounded, and if that system produces the output signal whose all the values are also bounded, then I can say this system is a Bibo stable system. Simple sense way to define. Now, suppose for example, if I take an example, suppose yn is 1 by n square. A small example, very small and very easy example. Now, this is an equation that actually describes the characteristics or describe a system or characterize a system. Suppose if any system is described by this equation, and if it is asked whether this system is stable or not, the obvious answer will be just by looking into this. Can anyone tell me what would be the answer?
Yes, sir.
Yes, proceed.
It will be a stable system, sir, because if n to the power infinity, if it goes, it will be 1 by 0. I mean, 1 by infinity, that will be 0.
And what happens for n equals to 0?
It will be infinity. Okay.
Then?
No, then it may not.
Then as per this definition,
Yeah.
sorry, it will also be. Okay, understood. So actually it is an unstable system. Fine, it is an unstable system. Okay, now sometimes the same example can be written like this. Xn by n square. Xn by n square. Then it actually depends on the extent of xn. Extent of xn, that means how long xn actually exists. Now, if xn exists for all the values of n, means for the, or in general, you can say for the practical purposes, I just want to reduce the numbers. So suppose 0, a few positive values, a few negative values. That means if it is so, then it is not a stable system. It is not a stable system. So, but xn, if for n equals to 0, that means for n equals to 0, whenever you will put n equals to 0, and if the signal exists for n equals to 0, then it will be unstable. And now we can argue that even if x equals to, for n equals to 0, even if the xn is 0, then it will be 0 by 0 form. In 0 by 0 form, it's kind of undefined form. You cannot define anything. So again, in that sense, you at least the conclusion you can make, it is not stable. Okay, so the stability actually in this kind of representation. Okay, anyway, so the next example I can take is suppose the moving average system. Okay, the moving average system. Let's once again write the expression summation. Average over m number of samples, and it should range from k equals to 0 to m minus 1. So total would be n number of samples, x of n minus k. This kind of definition, you know, mathematically, you can define like this. Now, if anyone asks that whether this moving average system is a Bibot stable system or not, suppose to check it, first you have to understand this, that first you have to consider that if xn is bounded, the term is called the bounded, no? Xn is bounded. That means no values of xn for any values of n will blow up. That is called the bounded. So xn is bounded. Suppose it is bounded by bx. Bounded by bx. That means that implies what? What I'm trying to say, that means suppose mod of xn, all values, for all values, that at least should be less than, or sometimes you can also put the equal to sign, doesn't matter. Okay, equal to less than bx, which is less than infinity. That means it is a finite value, some finite value. Okay, equal to sign. It doesn't matter actually whether you put equal to sign or not. Doesn't matter anyway. So less than infinity. Now, obviously, now if all the xn's are bounded, okay, then if you put it here, then what you can write? If you just check the condition, what you have to check? That mod of yn, you have to check, and you know how your system behaves. This is the expression. This is the relation to express the system or behavior with the characteristics of the system. Now that should be less than or equals to 1 by m, and summation over all the m numbers of xn. All the m numbers. Here it is m numbers of xn summed up. And here to consider the worst case, just consider the worst case, you just consider all the samples have a value maximum bx, though it is not true. Okay, but for the time being, just consider that all the m samples have the same value, that is bx, and bx is the highest allowed value, which is finite, which itself is finite. And it may so happen not all the values, all the samples have a bx value. Some samples have a less value than that, but doesn't matter. We are going to with the highest or the worst case considered. So k equals to 0 to m minus 1. Now, if you add up all the bx's, m bx's rather here. So m bx is divided by m, so it will be nothing but your bx. See, it is the worst case scenario. It is the worst case scenario. So basically, we put all the xn's, m number of xn's equals to their bounded value, or the maximum value, or the upper bound value, whatever you can say. And in that case also, what means what appears that your mod yn is bx, which itself is bound, but means finite. This is finite actually, as per definition. So that means this system is also Bibot stable system. So this is the way to explain actually. Fine. Similarly, you can take the example of suppose ধরো accumulator now. Suppose accumulator yn equals to, suppose if you define it like this, k equals to 0 to infinity x of n minus k, suppose এরকম ভাবে you define in this way. So the question is whether it is stable or not. Whether it is stable or not. Summation is from k equals to 0 to infinity x of n minus k. কে বলবে দেখি?
স্যার xn bounded, yn bounded কিনা সেটা চেক করতে হবে।
Exactly. xn is bounded, no doubt. xn যদি bounded না হয় তাহলে আর চেকিং এর প্রশ্নই নেই কোনো, ঠিক আছে? তো যখন এরকম প্রশ্ন আসবে তুমি ধরেই নেবে এটা implied যে xn is bounded, all the xn values are bounded.
স্যার তাহলে yn ও বাউন্ডেডই হওয়া উচিত, কজ আমি কতগুলো ফাইনাইট ভ্যালুস সাম নিলে ওটা ফাইনাইটই হবে কিছু একটা।
সামেশনটা তো ইনফাইনাইট অবধি করছো।
ও হ্যাঁ, তাহলে আনবাউন্ডেড হওয়া উচিত।
Sure. Under all cases or in general this statement can be made. একটু ভালো করে দেখো, ভালো করে ভাবো। তোমরা কনভার্জেন্স এন্ড ডাইভারজেন্স অফ ইনফাইনাইট সিরিজ পড়েছো ম্যাথমেটিক্স, বিভিন্ন টেস্টস মেথড।
হ্যাঁ স্যার।
সেইটার পার্সপেক্টিভ থেকে ভাবো তো কি হবে তাহলে উত্তরটা। যে ম্যাথমেটিক্সটা করে এসছো তারই অ্যাপ্লিকেশন এটা। Suppose all the n minus k, all are basically the input samples, na? All the input samples having the value 1 exactly equals to 1. So from 0 to infinity, you start on adding all the ones. সেক্ষেত্রে কি হয়ে যাবে? সামেশনটা কি হবে? yn এর ভ্যালু কি হবে? Means as n goes to infinity actually বলতে চাইছি, সেক্ষেত্রে কি হবে? আউটপুট কি আর বাউন্ডেড থাকবে? even though xn's are bounded? থাকবে না, তাই তো?
না স্যার।
থাকবে না। আচ্ছা, এইভাবে তুমি যদি বিভিন্ন এক্সাম্পল নাও,
স্যার
ধরো তুমি,
ফ্র্যাকশন হলে বাউন্ডেড হতে পারে।
হ্যাঁ ঠিক আছে, ঠিক আছে। তো অ্যাকচুয়ালি জেনারেল উত্তরটা এরকম হওয়া উচিত যে অ্যাকচুয়ালি এটা ডিপেন্ড করবে এক্স এন মাইনাস কে এর যে ফর্ম আছে বা ভ্যালু আছে তার, ইট শুড ডিপেন্ড। ঠিক আছে, কারণ তোমার ইনফাইনাইট সামেশন মানেই যে সবসময় আনবাউন্ডেড হবে তার কিন্তু কোনো মানে নেই। ইট ডিপেন্ডস অন দ্য সিরিজ, মানে তুমি যে অ্যাডিশনটা করছো ইনফাইনাইট সিরিজ, এটা তো বেসিক্যালি ইনফাইনাইট সিরিজ। সো ইনফাইনাইট সিরিজে যে অ্যাডিশনটা করছো সেটা টেস্ট মেথডের উপর ডিপেন্ড করছে, তার কিছু রুলস আছে, অনেক ক্রাইটেরিয়া আছে, তোমরা জানো। তো সেটাকে অ্যাপ্লাই করতে হবে, করে টেস্ট করে তোমাকে দেখতে হবে যে ওটা ইনফাইনাইট হবে কি ফাইনাইট হবে, বুঝতে পেরেছো? So just by looking into this, you cannot draw any conclusion. It actually depends on the values of the xn's, rather, or different values of the xn, or different samples of the xn. তার উপর ডিপেন্ড করবে এটা মেনলি, তারা কিভাবে অ্যাড হচ্ছে বা কি কি ভ্যালু তাদের আছে, কিভাবে অ্যাড হচ্ছে আপ টু ইনফিনিটি, লাইক দ্যাট। বাট দিস ইজ, এটা এটা আমি একটা ইন জেনারেল উত্তর বললাম, ঠিক আছে? তো এবার ধরো সিস্টেমটা এরকম represent করা আছে in this way, and the signal that I'm feeding, actually this signal, they are of finite length. They are of finite length. That means suppose xn exists from, suppose for example, finite bolte আমি বলতে চাই ধরো xn exists from 0 to suppose n minus 1. That means the length of the signal is n. Okay, then under, if you feed this signal to this system which actually sums up infinite number of values, means keep on summing up, করেই যায়, যোগ করেই যায় এরকম কাইন্ড অফ, ঠিক আছে? তাহলে এই ক্ষেত্রে কি হবে, বেসিক্যালি যে সিগন্যালটা তুমি ফিড করছো, দ্যাট সিগন্যাল হচ্ছে ফাইনাইট লেংথ, finite number of samples are there. But in that case what would happen, actually you just try to draw the picture. Suppose 0 থেকে শুরু করো, starting from 0 up to n minus 1. Suppose for example you have all the non-zero values, suppose that all are bounded, fine. Now rest of the values are 0. Okay, rest of the values are 0. Now there is no point, basically if you feed this to this system, after n minus 1th sample it will basically keep on adding, because of the characteristics of the system is such that it will basically keep on adding the zeros, because originally the signal has no sample, no more sample. So basically it will keep on adding the zeros, and you know that basically summing up the zeros will not give any new information. So that is why it is equivalent to summing. It actually depends on the type of input you are giving. If it's a finite length input, then there is no problem, it's always be bounded. But if it's infinite length input, then actually it depends on the nature of the input, how the input value changes it on that. Because the example I have given, if you add up all the ones, then it will be not bounded. Okay, like that. Anyway, now a very tricky question that is asked different times, that is stability, you all know about the stability, you have learned about the oscillator, the Barkhausen criteria, etc. So this, whether the stability, you know, inherently related to feedback, is related to feedback, inherently related to feedback, stability, always it's with the feedback. The answer would be, it is a common question, generally it is asked in the interview also. The answer would be not necessarily, because I already demonstrated an example, yn equals to xn by n square, this example. If you just look into that example very carefully, you just see that there is no feedback. Actually, xn by n square, there is no feedback. Fine, no storing or retrieving it for the very next instant, nothing like that. Okay, so no feedback, no recursion, although it is an unstable, at least not stable. But of course, the the example you in the example of this accumulator. Suppose the example in the previous example, actually the example of the accumulator, that also that can be written as a feedback system, and it can be computed with the feedback. That can be written. I have already done it in the class. Now, it is true that instability also occurs with the feedback. That is true. Okay. But suppose the sequence itself is unbounded. Then, of course, the output will be unbounded. Suppose input itself is unbounded. Then the output will also be unbounded. There is a possibility. There is a high chance, high possibility. But again, in general, it is true that stability is inherently related to the feedback. A non-feedback system, that means a system where there is no feedback kind of thing, cannot usually be unstable. Please note the word I have used, usually be unstable. But it is not that it will never be unstable. This is not true. No one can claim that. Okay, but usually it is not unstable. And mainly stability related to the feedback. That is true. But there is an exception. And without feedback also, stability, the question of stability could be arised. Sorry, can arise. Okay, that is possible. The example that I've already cited. So you should answer like this. Means at least one counter example you should produce to this at least to disprove the conventional belief or the statement given. Okay, at least one counter example in general. Okay, next we should talk about suppose if any system is given, any one example I'm giving for you, just you do it by yourself. Okay, you just do it. Suppose a very simple example I'm taking for you. Suppose yn equals to alpha x of small n minus capital N. You just see this is a difference equation that is basically describing any digital system, a particular digital system, or characterizing a particular digital system. Okay, now the question is whether this system is okay, I'm not giving it as an example. I'm trying to explain this for you. I think it will not be wise to give this as an example for you. Anyway, the point I want to mention here that actually here I am interested to talk about that alpha factor. Okay, I'm not giving it as an example this time. I'm going to discuss it in the class. So I'm going to set another example for you. So the question is whether this is a passive system or not. This is actually a passive system or not. Now here, whenever you will talk in terms of the active or passive system, you have to basically look into this factor alpha. So x n minus capital N is being multiplied by alpha, and then it is producing y of n. Now, if you take the mod of alpha, because in general I have to take the mod, if it is less than 1, the system is a passive system, obviously. Now, the concept of passive system, of the passivity, I think you people are already familiar for the analog systems. You know that the energy of the output cannot exist to the energy given to the input. You know that quite well. Okay, so always in most of the cases, what happens? Whatever energy of the output signal you get, generally that is the less than the energy given to the input signal, given or fed to the input actually. And anyway, so that is basically, it depends on the value of the mod of alpha. Okay, if mod alpha is less than 1, then it is obviously passive, you can understand. On the other hand, if mod alpha is greater than 1, this you can say this is an active system. Okay, but a passive, it is actually a digital system in general. You just see a passive digital system can be made active just by multiplying it. Just see, by multiplying an arbitrary number. If you select the number or choice, because alpha multiplication is, what is this? Scalar multiplication. I've already shown in the class how to represent that block diagram in the form of block diagram or something like it. It's just a scalar multiplication. It's a linear operation, you know. It is not a multiplication of a signal by another signal. It's just a scalar multiplication. That means all the samples of this signal will be multiplied by alpha equally. Okay. Now, as far as the definition, if you borrow the concept of active and passive circuits or elements or something like that from the analog counterpart or analog systems, and if we apply the same concept here for the digital system, so just you see that this active or passive nature becomes so easy to implement. You are actually, the passive system can be made active just by multiplying a number.
Sir,
Bolo.
so we don't know what is active and passive system.
Hi, এটা কি করে হয়? তোমরা সার্কিট থিওরি নেটওয়ার্ক পড়ছো না? অ্যাক্টিভ প্যাসিভ জানো না?
So just দুটো ক্লাস হয়েছে স্যার সার্কিট থিওরি।
ও আচ্ছা, তাহলে আমি একটু বলি, কারণ এটা আমার টপিক নয় যদিও। যাই হোক, আমি একটু তোমাদের সুবিধার জন্য একটু বলে দিচ্ছি, ঠিক আছে? সাইডে যারা জানো তারা জানো, আর যারা জানো না তারা একটু দেখে নাও। অল্প করে বলছি, আমি জাস্ট একটু সামারাইজ করছি। অত ডিটেলস তো বলা সম্ভব না। দেখো, একটা সিঙ্গেল লাইন আমি অলরেডি অবশ্য বলেছি, দ্যাট ইট ইজ বেসিক্যালি রিলেটেড টু দ্য এনার্জি অফ দ্য আউটপুট। Okay, if the energy of an output signal of the system, actually in general the energy, it is expected that the energy of the output of a system, cannot exceed the energy of the input. Now, if you say that your digital system is passive, that means this particular criterion is satisfied. That means, suppose if you write from the energy of the output, what is the energy of the output? How to calculate? The energy of the output, the concept is same. I'm basically borrowing the same concept as applicable for the analog part or for the continuous time part. Just to see, if you want to calculate the energy, what you have to do? You have to take all the samples, okay, the mod value of all the samples, and you have to take the square of that and sum over in general from clear way. Minus infinity to plus infinity. You know how to calculate the energy. You know that. So this is, if you calculate this energy from the output, okay, then as I mentioned, at the definition mentioned, the output energy of the output cannot exceed the energy of the input. So it should be less than the energy. Energy means actually again of the input side. If you calculate from the input side, that means xn. If you take all the mod values and square and summed over all the values of n from minus infinity to plus infinity, okay, if this particular criterion is satisfied, this condition is satisfied, then we can say this digital system is a passive system. In other words, the system cannot generate energy. That is the conclusion you can draw. Okay, that means, suppose for example, a simple RLC network. You know the examples, different types of LR, RL, RLC combinations. I think you have been doing in the class, okay, in the network class. So this is a passive network.
Yes, sir.
Yeah, this is a passive network. Now, on the other hand, if you have a RLC network, suppose, or any combination of R, L, and C, with suppose in combination with suppose op amps. I don't know whether you have heard the name of op amps or not, or say suppose transistor BJT, bipolar junction transistor, suppose, okay, BJT. If it is combined with that, now then that will become an active network. Now the question is, where active means what? Active means that's the opposite, no? Active means your energy of this output will be greater than to the greater than from that of the energy of the input. Now the question obviously comes that where from this extra power or energy you are getting, or your network or circuit is getting. Okay, that means where does the extra power actually coming from? Where from it is coming? Because when you have a simple RLC or any combination of R, L, and C, I am saying, or even diodes also. Okay, I am saying it is active, passive network or circuit. But when I am saying there is a op amp combined with that, or any kind of transistors combined with that, I am saying no, it is not passive, it is the active network or circuit. Though there is a technical difference between the as far as the technical definition is concerned, there is a difference between the network and the circuit, but I am not going into that. Okay, I'm not want to do any kind of jugglery with these terms, network, circuits, etc. But just I am using interchangeably. Fine. So anyway, so then I can say it is my active network or circuit. But why I'm saying it is active? That means the energy of the output is more than the energy of the input. Now the obvious question is, where from we are getting this extra energy or extra power? So only source is that the question whether the device is generating something from within. And if it is so, where from it is getting? So basically you have the power supply. You should remember this thing. Whenever you will operate any kind of this kind of transistors or any active elements in general, op amps, transistors, etc., you have to apply extra source, power source to that. Besides applying the input to a particular terminal, you have to apply some additional power source. Maybe in that terminal or in some other terminal. So you will learn these things in details when you will get exposed to these circuits and all this, analog circuits and so on. This course you will learn everything. Just to take it as a piece of information. So there, this extra power, that is called a supply. Please remember this thing. This supply actually provides that extra power. That is not coming from the input. This power is not coming from the input. That is coming from the supply. The supply and the input are different things. And for the resistor, capacitors, inductors, or diodes, or this kind of passive elements, whenever people talk anything, any regarding passive elements, there you only apply this input signal. No extra power source is applied. That is why they are active. No, sorry, they are passive. They are not active. But for transistors, op amps, etc., even for the diode, you don't need to apply any additional power supply. Just to apply the input. Okay, so this way you can say that which one is active, which one is passive. And accordingly, for the active elements, the power is basically drawn from the extra supply that you are giving, okay, or providing. And that is why when you calculate the power of the output, it seems that the power increases from that of the input, because the extra power is coming from the supply. In this way, they are active, actually, as per the definition is concerned. Now, এবার কি বোঝা গেল কিছুটা মোটামুটি? মানে খুব শর্টেই তো বল, হ্যাঁ এইটুকুই বললাম অন্তত, ঠিক আছে। আচ্ছা, আরেকটা পয়েন্ট যখন তুমি জিজ্ঞেসই করলে একটু বলি, যেখানে দেখবে এটা আমি তো এখানে বেসিক্যালি মানে ইনইকুয়ালিটি রেসপেক্টে বলছি, মানে যে এটা যদি বেশি হয়, ওটা যদি বেশি হয়, কাইন্ড অফ দ্যাট। মানে অনেক সময় ইকুয়ালিটি সাইনটা রেসপেক্টও বলা হয়। সাপোজ ইফ দ্য আউটপুট এনার্জি ইজ ইকুয়ালস টু দ্য ইনপুট এনার্জি, তাকে আমরা কি বলবো সেই সিস্টেমকে? মানে এক্স্যাক্টলি আউটপুট যা এনার্জি পাচ্ছ সেটা ইকুয়ালস টু দ্য ইনপুট এনার্জি, বেশি কমের দিকে যাচ্ছি না। কম হলে তো বলছি প্যাসিভ, বেশি হলে বলছি অ্যাক্টিভিটি লাইন। তার জন্য আবার লোকজন একটা আলাদা নাম ডিফাইন করে রেখেছে, সেটাকে বলছে লসলেস সিস্টেম। লসলেস মানে যেখানে তুমি ইনপুটে যা দিচ্ছ আউটপুটে তাই পেয়ে যাচ্ছ, কোনো লস হচ্ছে না, ঠিক আছে। অ্যান্ড অবভিয়াসলি এটা কাইন্ড অফ একটা মানে লসলেস সিস্টেম না, কাইন্ড অফ বলতে পারো একটা আর্টিফিশিয়াল কনসেপ্ট, একটা হাইপোথেটিক্যাল কনসেপ্ট, ঠিক আছে। মানে এইভাবে যে মানে সত্যি কথা বলতে লস একদমই হবে না, তুমি ইনপুটে যা দেবে আউটপুটে তাই পেয়ে যাবে, কোথাও কোনো লস হবে না, মানে এটা তুমি জানো যে এনার্জি কনজারভেশনেও এটা ঠিক হয় না এইভাবে জিনিসটা ঠিক এনিওয়ে বাট কনসেপচুয়ালি ম্যাথমেটিক্যালি অ্যাট লিস্ট ইউ ক্যান রাইট অর ইউ ক্যান ডিল উইথ দিস কাইন্ড অফ থিংস ওকে আচ্ছা আরেকটা পয়েন্ট একটু বলি যখন এই পয়েন্টগুলো উঠছে আর একটা বলি এই যে আমি বললাম না এক্ষুনি যে just now I discussed that energy আমি অলরেডি ফর্মুলাটাও লিখে রেখেছি energy of output energy of input in the context of a digital systems ওকে আমি যখন বললাম দেখো একটা কথা মাথায় রাখবে ডিজিটাল সিস্টেম মানে যে সিস্টেম ডিজিটাল সিগন্যাল নিয়ে ডিল করে ঠিক আছে তার উপর প্রসেস করে আউটপুটও ইনপুটও ডিজিটাল সিগন্যাল নেয় তার উপর প্রসেস করে আউটপুটও ডিজিটাল সিগন্যাল প্রডিউস করে ইন সিম্পল ওয়ে ইউ ক্যান ডিফাইন লাইক দিস নাও দ্য পয়েন্ট ইউ শুড রিমেম্বার ওয়ান থিং বেসিক্যালি হোয়াট ইজ দিস these are nothing but some numbers say but just go back to the origin go back to the root recall that digital signals when you define digital signals or discrete time signals these are nothing but the numbers so the concept of energy in the numbers is not in that sense true please note it carefully it's a very technically it's wrong এই যে ফ্যালাসি গুলো আছে না এই জায়গাগুলো একটু বুঝবে এগুলো ব্লাইন্ডলি পড়ে যাবে না কারণ ইন্টারভিউতে আটকে যাবে তাহলে হ্যাঁ এই কনটেক্সটটা উঠলো বলে আমি বলছি তো ডিজিটালে আমরা বলছি বাট ইটস দ্য এনার্জি অফ দ্য ইনপুট আউটপুট এন্ড অল দিস স্টাফস কিন্তু ইন দ্যাট সেন্স ইট ইজ নট এনার্জি বিকজ হাউ টু ক্যালকুলেট এনার্জি ইউ নো দ্য ডেফিনেশন এনার্জি ইজ মাইনাস ইনফিনিটি টু প্লাস ইনফিনিটি mod of xt squared dt you know the area under the curve যে সিগন্যালটা থাকবে যে কার্ভটা থাকবে তার স্কয়ার তার অ্যামপ্লিটিউড স্কয়ার তার আন্ডারে যে এরিয়া সেটাই হচ্ছে তোমার অ্যাকচুয়ালি এনার্জি তো এখানে তুমি এরিয়া ফাইন্ড আউট করবে কি করে তুমি তো এরিয়া ফাইন্ড আউটই করতে পারবে জাস্ট নাম্বার কিছু নাম্বার আছে and mostly এই অ্যাক্সিসটাই তো টাইম নয় most importantly the axis is not the time axis it's just a number so basically in that sense na the concept of energy in numbers is actually not true because digital system only handles some numbers that's all but we are kind of you know due to some convention and to find a similarity or to establish a link with our already well-known concept for the analog systems or the continuous time system we are introducing this term of energy or relating the term of energy with this so that the understanding would be easy for our convenience that's all but technically this is not true this cannot be applied like dc যেটা আমি তোমাদের বলেছিলাম dc তো সিগন্যাল নয় তো টেকনিক্যালি dc কে সিগন্যাল বলা যায় না ডাইরেক্ট কোনো কিছু এটা হচ্ছে ফিক্সড ভ্যালু ইট ইজ নট এ সিগন্যাল বাট উই সে না dc সিগন্যাল অনেক জায়গায় অনেক বই আর কি তোমার লিটারেচারও আমি দেখেছি dc সিগন্যাল লিখতে এবং মুখেও তো বলে আমিও তো বলে ফেলেছি সো এটা হয়ে যায় এটা ওই আমাদের একটা ব্যাক অফ দ্য মাইন্ডে চলতে থাকে না এটা অটোমেটিক্যালি চলে আসে ঠিক আছে এটা সাইকোলজিক্যাল ব্যাপার অ্যাকচুয়ালি ওকে সো বাট ইউ শুড আন্ডারস্ট্যান্ড অ্যাট লিস্ট ইউ শুড নো হোয়াট ইজ রং অ্যান্ড হোয়াট ইজ রাইট even though you are doing something wrong okay not consciously of course but still you should understand what is wrong and what is right okay anyway so that is the point I want to mention so and this energy is in the sense of the analog system or the analog signal means just to borrow or continue the concept of analog systems and analog signals or signals we are just kind of plugging the sense here but actually the sense of energy is not applicable in true sense quote unquote for the discrete time cases okay just you should know it anyway আমি কোথায় চলে গেলাম কি বলছিলাম সব আমি কি বলছিলাম বলো তো অ্যাকচুয়ালি কেউ একটু বলো কোন জায়গাটা আমি কি বলছিলাম সেখান থেকে অনেক দূরে চলে গেছে
লেফটে যে সিগন্যালটা লিখে রেখেছেন ওইটার ব্যাপারে ওই আলফার ভ্যালু
আচ্ছা আলফার ভ্যালু না হ্যাঁ আচ্ছা তাহলে দেখো সো আমি যদি এই এক্সাম্পলটা নিই তো আমি যদি জিজ্ঞেস করি whether it's a passive or active system তো তোমাকে বলতে হবে যে এখন তো নিশ্চয়ই বুঝতে পেরেছো যে if you take if the value of the mod alpha is less than 1 it is of course passive on the other hand if it is greater than 1 it is active so that means you know for a digital system can be active you have to just multiply it by some arbitrary number you just scalar multiplication the analog just you try to represent this thing this equation in a block diagram form or in your schematic representation, just represent. You just think this alpha is nothing but a scalar multiplier. So just by multiplying or just by changing the value of the alpha or the multiplier, the value of the multiplier, and still it's a linear, it is not a non-linear operation. And in every now and then you can resort to this kind of operation. So this is very easy, na? It is not so complicated like what we experienced or have been experiencing for analog or continuous time domain case. So we can always increase the energy by scalar multiplication. That is why this is again a artificial concept. That is why it is again an artificial concept, just introduced for the purpose of analysis and design. So that already we have a preset mind. The mind is already preset. We are already used to observing or analyzing and designing these continuous time domain and or the analog systems. So just to relate or just to link up with that, so that we can move with our preset mind, this concept is again invoked here. Again, the concept of that your scalar multiplication means the system becomes active. But that is not true. Activeness cannot come from just by multiplication. In that sense, it is not true. But that is why again it is an artificial concept. So the active system, if it's a digital, this activeness of the active system, kind of artificial concept. Because ultimately active systems in digital means what? You are just multiplying it. You're doing a scalar multiplication. The mod value of this is greater than 1. Things are not so simple. Conceptually, we can carry out this concept. We can basically continue with the concept of analog that is coming from the analog. So that is, it's kind of analogous. So that is why we are here also bringing and applying the concept of your activeness and passiveness in this way. But actually, it is nothing but a simple scalar multiplication. If you go inside, if you look into the inside, it is just a scalar multiplication. So in that sense, again, for the digital system, this concept of activeness and passiveness kind of, let's say just the artificial concept. It is introduced just to relate the concept you already have, and that is only for the purpose of analysis and design. So this kind of concept of energy and this activeness, passiveness, all these are people talk in terms of the digital systems, but again you should understand that why it is technically not correct. Anyway, আচ্ছা তোমাদের জন্য যে এক্সাম্পলটা দিই সেটা হচ্ছে কি দেওয়া যায়, আচ্ছা একটা সহজই কর, সাপোজ এটা তোমরা প্রত্যেকে করবে, yn equals to x of minus n. Simple example. It is a time reversal system. Now the question to be asked, actually this question has 3-4 parts. The first part is, everyone please note it. So is the system linear? And you have to give proper explanation against your answer, or means whatever means your claim has to be properly you have to give proper argument against your claim. So the first question is that whether it's a linear system or not. Okay, you have to explain it. Just yes or no will not going to work for you. You will not get any number just by writing yes or no. You have to explain, you have to give proper argument. Now second part is whether this is a causal or not. Okay, whether this is a causal system or not, again you have to give argument. Okay, third one is whether this is a time varying or not. it's a time varying system or not. Fine. Fourth one, কি দেওয়া যায় আর কি হলো, লিনিয়ারিটি হলো, কজালিটি হলো, টাইম ভ্যারিয়েন্স হলো, আচ্ছা স্টেবল অর নট। The fourth one is the stable or not, whether the system is stable or not. And the fifth one is, এটা এখন ডিসকাস করলাম, প্যাসিভ, whether the system is passive or not. ঠিক আছে, সো এই পাঁচটাই থাক আপাতত। এইগুলোকে তোমরা এক্সপ্লেন করবে এবং অ্যাকর্ডিংলি ইয়েস অর নো এটা বলবে। ওকে, আচ্ছা এবারে
ওকে স্যার,
এটা তোমরা নিজেরা করবে, কিন্তু আমি হয়তো নেক্সট দিন বা নেক্সট টু নেক্সট দিন আমি জিজ্ঞেস করবো। দিলাম মানে এটা নয় যে রেখে দিলাম, ওকে, এটা কিন্তু করবে একদম।
ওকে স্যার।
আচ্ছা এবারে আমরা একটু ডিসকাস করি রিগার্ডিং দ্য ইম্পালস রেসপন্স and the step response of the LTI system. That is extremely important part of our course. Impulse response. You already know some idea what is impulse response and what is step response of the system is, but again I have to introduce, and the reason will be clear within next day. Suppose we have a digital system. It's a digital system, and this digital system I'm applying impulse function del n. You know the definition of del n quite well, and I'm applying this to the input of this system, digital system, and whatever output I'm getting the output terminal is generally mostly denoted by this letter hn. H of n, okay, H of n. And this H of n is called the impulse response, or better to say the unit impulse, specifically because it's a unit impulse function. So unit impulse function, response for this system, for this digital system. Okay, unit impulse response for this digital system. Now, how to define? Suppose if hn is 0 for n less than 0. Please note it carefully. If hn is 0 for n less than 0, then the system is causal. আচ্ছা আরেকটা কথা বলি, এটা কিন্তু উচ্চারণটা হচ্ছে কজাল, ক্যাজুয়াল না, হ্যাঁ, অনেকে আবার ভুল বলে ফেলে, কজাল, ঠিক আছে, the system is causal. So কেন, দেখো, it is another way to define. Please note, this is, so far we have discussed in terms of the input output x and y n to define the causal system or something like that. But here we are defining, this is also output, no doubt, obviously, when this delta function is applied as an input, but still it is called the unit impulse response or impulse response for the system. Actually, this is a very powerful tool to characterize any system, any LTI system. It is a very powerful tool. The impulse response is a very powerful tool to characterize a system. That means, in another way, you can say that it actually gives you all information that is required to define a system. All information that is required to get a proper understanding or view about the system, it gives. So that is why it is so powerful. So if you apply the input a impulse function, the output, whatever you will get, is called the impulse response, and that impulse response became the characterizing tool for the system. That is why you will find that this hn is written here, because it actually describes the system, it actually characterizes the system, it actually defines the system. So every information, every bit of information, or you can say all information, is hidden within this hn. That is the form of hn, or the expression of hn. Okay, hn is actually very, very powerful tool to describe the system. Okay, now that is, you just see one thing, that means in your system, basically in general, it is said that agent is equivalent to a system, which actually defines the system, it describes the system, it characterizes the system. That is why it is equals to that or equivalent to that kind of. I should not say equal, but then equivalent. Okay, agent. So agent is actually your equivalent to a system. Please note. So in place of system, in place of this box, if you just erase this box, just to hypothetically conceptually think that you are, no, just a minute. I should not use this eraser, I should use a soft eraser. So I think it will be easy for you to understand. Yes, this one. This is a soft eraser.
Sir.
Bolo.
Sorry to interrupt. We have another class from 4:30.
4:30 এখন তো সময় আছে আর 5 মিনিট করে দিই ঠিক আছে 5-10 মিনিট
হ্যাঁ স্যার বলে দিলাম
হ্যাঁ ঠিক আছে 4:30 থেকে কার ক্লাস এবিএস এর
হ্যাঁ স্যার
ওকে আচ্ছা দেখো আমি এখানে দেখো এই লাইনটাকে একটু দেখলে একটু এটা ইন্টেন্সিটিটা কমিয়ে দিলাম লাইনটা ঠিক আছে তো লাইট করে দিলাম এটা মানে হচ্ছে সাপোজ হাইপোথেটিক্যালি তুমি যদি চিন্তা করো এখানে তোমার সিস্টেমটা নেই এই মুহূর্তে just you have this HN. So what is HN? HN was the output signal the system was producing. Now you have just taken this signal to characterize this system, to define this system. So this HN is kind of actually a signal. Please note it. HN is actually a signal, but it is now as acting like a system, representing a system. It is equivalent to a system. So if this is called, so now there is no system, just to remove all the boundaries of the system. You just remove, throw it out. And you just place another signal agent. So that means now whatever input you will apply to this system, which is no longer a system, suppose, because the system is replaced by a signal which is equivalent to that system. Okay, now if you apply input, suppose xn, this xn is going to interact or interplay with this hn to produce what is called some output, in general arbitrary yn. So that means my system is actually, I can replace my system with a signal. Then the system is behaving like a signal, or in other words you can say the signal is behaving or acting like a system. Both are true. And how we got this signal? We got it this way. When we apply an impulse function in the input, whatever output we get, that output actually can characterize, has the capacity or the power or the information to define this system. So it's a characterization tool or characterizing tool, this agent. So ultimately, basically what reduced is that actually it is ultimately the interaction between the two signals. You just remove the boundaries of this system. You just forget about the term system. System itself has no meaning now, because everything we will talk in terms of the signals. Everything is now signal, whether that is hn, whether that is xn, yn, and so on and so forth. All are now become signals. Have you got this concept? So it is kind of equivalent representation. It is equivalent representation of the system. Fine. Now, suppose your hn is 0 for n less than 0. If this is the case, then the system, as I mentioned, it's called the causal. Because why it is called causal? You should understand the reason. The reason is because delta n, look at the delta n. Delta n actually comes at n equals to 0, na? At n equals to 0. It exists only at n equals to 0. Now, if the system has output before n equals to 0, then the system is not causal. Are you getting the point? I can define, that means it is another way to define a causal system. hn equals to 0 for n less than 0, and that will be true because you are applying the delta, you are getting the hn because of the application of delta n. And when you have applied the delta function is applied only at n equals to 0. Before n equals to 0, there is no existence of delta function. So naturally it is expected there would not be an existence of hn because we haven't applied the delta yet. So that is the definition. That definition comes from here. hn equals to 0 for n less than 0. If that is true, then the system is causal. If that is not, that means before application of delta at n equals to 0, if system produces something, suppose if produces, then the system is non-causal. So that is another way to define. And you just see the analogous definition you used just now, we discussed at the beginning of this today's class, what is the definition we make? To define a causal signal, just you see, xn equals to 0 for n less than 0. Can you relate now? These two. This definition actually comes from this. This is fast, this is not fast. But the way we read, this fast, this last. That is not the true. That is not true. That is why people got confused with this definition. The definition of the system comes first in terms of its impulse function or impulse response. That Hn is 0 for n less than 0, and that is the reason, because of the delta, existence of delta. And just to make the thing similar looking, the definition of your causal signal is like this. So that people do not get confused. The definition will look like same, but conditions will look like same. Got it now, the concept? Is it clear?
Yes, sir.
Okay. তাহলে আজকে প্রসিড করে লাভ নেই, এই অবধি থাক। আপাতত ক্লিয়ার করি, আর তোমরা একটু কানেক্টেড থাকো, তোমাদের অ্যাটেন্ডেন্সটা নিয়ে নিই।